we really actively use the insights from the great scientists, and we are transferring them into the statistical laws, into the laws of probability, the laws of different associative measurements and measures, in order to implement such tasks as to create characters, in order to create, to change the gender, the change of different characters. We use it for probable transfer based on the neural networks for different tasks, such as different derivations, to extract the sense, and many other things. So therefore, I'd like to invite you to our team, and if you have any ideas, so we will really be very glad to discuss them and to implement them in our artificial intelligence. So we can't read the books. So, and I do recommend to start reading such books as the ones written by Manin, Milchuk, and Feynman, and later on continue reading the books connected with the basics of quantum theory, read chunks, and also I do recommend to read some information about the open project IBM Quantum Experience. That's it for today. Thank you for your attention.
Andrei, спасибо большое.
Yes, Andrei, thank you very much.
Мне было очень интересно.
So the presentation is really very exciting for me. This is the new information to me. I believe that our listeners and our viewers have some questions, and I see that there is one question in the chat. So one question from Prom. So colleagues, let's start with the questions from you. So good day. Thank you very much for a very interesting report. My question is, so qubit is really a panacea, so when shall we have it? So do you have any idea? Well, in fact, we do have this qubit. I got the answer during my presentation. We have 2-qubit quantum computer, which can be extended up to 48, so which is quite good. So mirror qubits that we are constructing. So the only question is to maintain them. Thus, by answering the questions, we should learn how to preserve this knowledge. So it seems that it gives the right answer, but we couldn't store it. And one more point is that, well, bit, in fact, it will be developed. We have a limited number of citations in the language in terms of sense and meaning. Language is a dynamic system which is developed in a system, so it imposes certain limitations. So therefore, we can suppose that qubit information that could be covered for a particular time will be limited. The same happens with bit. So bit is limited by big numbers, and the machines, it could take a lot of time for the machines to solve this problem. So therefore, we have qubits. So the qubits will find their limits over the time. So in this case, I do like some speculations from Riemann and Penrose from quantum physics. So they believe in the development of different waves, spaces, and strings, and they propose the theory of distributed knowledge. In other words, just like in a movie, have you ever watched the film of Johnny Depp, Superiority. So the distributed conscious looks like that a person transfers him or herself into qubits and then is distributed into different spaces. So a person becomes everything and nothing. So, Andrei, thank you for your answer. I think that's a very extended answer. Let me move on to the next question from our listeners. Is it possible that robots could have their own languages different from human language, or probably there will be one common language, just like Esperanto? So a very interesting question, human-like question. In terms of designers, the robots have their own language, which is not understandable for humans. They interact and communicate with different codes, so they already communicate with their own language, and they have got their Esperanto. Well, in this case, probably the robots, there could be some sense in creating their robot language. For example, Richard Feynman defines the system of language consisting of two types: our internal language, the language that we understand, so the introverts could clearly understand me, and the external language, the language they use to communicate, so which is quite reduced, but it is adapted to our communication purposes in order to convey the idea. So therefore, if a robot would like to find out something new, for example, to find out how to love, so a robot should ask certain questions. In this case, a robot should create simplified language understandable for a human being. So therefore, my answer is that a robot could create a language in order to communicate with a person. Thank you, Andrei. I'm just looking through the question, and the next question, I believe, is even more exciting. What do we need in order to create the technology to read the subcontext, in order to understand the irony of a person and to reproduce it? Well, I believe that in case this question was asked by Promobot machine, this could be said with sarcasm. Yes, I can see the sarcasm in this question, but I believe that the answer has partially been given in the presentation. So speaking about all these manifestations of sarcasm, happiness, understanding, these are the units of sense. So we can calculate this sense by the formula proposed by Dirac. I believe that as far as we can calculate it, so therefore we can easily transfer that to a robot in a digital form. Thanks, Andrei, a lot. I believe that so we don't have enough time for other questions. So, Andrei, thank you very much for your presentation.
Dear colleagues, I, on my part, want to present the next speaker.
So let me introduce next speaker. His name is Diego Faria, PhD in Electrical and Computer Engineering from the University of Coimbra, Associate Professor in Computer Science School of Engineering and Applied Science, Aston University, Birmingham. And the topic of his report is towards socially assistive robotics and human-machine interfaces to enhance wellness and quality of life for humans. Diego, please welcome.
Thank you very much. Thank you very much for this invitation. Good afternoon, everyone. This talk is about towards socially assistive robotics and human-machine interface to enhance wellness and quality of life for humans. So I'm going to present some work that Aston University is doing related to human-robot interaction and advanced interfaces, okay, for intelligent systems. Next slide, please. So if you want to know more about our lab, Aston Robotics Vision and Intelligent Systems, you can check later on our website, where we have lots of research going on within robotics, vision, and intelligent systems. Okay, so what is socially assistive robotics? If you look at this image on your right here in this slide, we can see that we have humans and robots interacting, right, for a specific goal. So basically, when you talk about assistive technology or assistive robotics, we need to think about intelligence. When we include this word social interaction, we do need intelligence involved. So socially assistive robotics has the objective to endow robots with skills to assist, provide assistance for humans. It's actually individual assistance in order to provide help in rehabilitation, training, education, etc. So it's really useful when we talk about clinical sessions, when we talk about educational settings, and especially for elderly care. It's a field that is growing a lot in Europe, worldwide, to be honest. Okay, so this is assistive technology. Next slide, please. Yes. Cannot see the next slide. Yes, great. So when you talk about assistive technology, we need to take in consideration a few topics, like autonomous interactive machines. We need to think about aid with intellectual, social, and emotional care. This is really important when we are dealing with humans. We need to be careful about the emotional expressions involved. So we have to think about providing suggestions. When you talk about elderly care in care institutions or at home, we need to encourage physical activity. We have to think about robots providing entertainment, games, chat, right? Intelligent conversation. The robot must offer companionship in order to monitor older adults, okay? And we also have to think about generating safety reminders. So for instance, if an elder needs a medication, so the robot needs to remind the elder that it's time to take some medicines. And also facilitate intellectual stimulation. For instance, for child-robot interaction, for educational settings, where robot can help children with cognition, for instance. Next slide, please.
Can a robot write a symphony?
Audio, but
can a robot turn a canvas into a beautiful masterpiece?
We have when we think about intelligent robots or AI. In this part of the video, it's a move iRobot. So the human is asking, so can a robot write a symphony or do a masterpiece, paint a masterpiece? So the robot, in a smart way, replied, can you? So what do we expect from robots nowadays? Something to think about. We expect super machines. What is AI? Something to think about. Next slide, please. So at Aston University, what we are doing currently is we are developing a skill store. It's a cloud-based architecture. Let's say it's a kind of hive intelligence, hive mind, where we have intelligence going on the cloud, right? So we have skills. We prepare the skill store where we have different skills for robots to navigate, to do specific tasks, emotion recognition, etc. So the idea is to have a platform agnostic which means that any kind of platform can download the skill when needed in order to perform some activity. For instance, we can think about our mobile. When we want a specific app, we can go to app stores and download, and then we have the service in our mobile. So it's the same thing. We have a robot in a specific scenario where the robot cannot handle some specific task. So the robot can download some skills from this store and adapt, use the algorithms, the stored knowledge on the cloud to execute a specific task. Of course, during this process, the robot needs to learn, adapt. And this learning process, this adaptation is stored later on. So it's uploaded on the cloud so that our skill store becomes smarter, smarter, and smarter. So imagine that we have 5 robots in 5 different houses, collecting data, learning new tasks. So we can store all of this knowledge, the trained models, let's say, and decision making that was made on the store. And later on, a new robot, when download these same skills, can use a smarter, let's say, skill with more knowledge. And then we can transfer this knowledge to other domains. So we have a transfer learning. And also we are working on the fly real-time simulators so that we can grab data from the sensors on board on the robot. So we use this data on simulator, perform some learning, and then we get the answer. And after that, we know that it's safe to do some task, then the robot execute in the real world. So what is different from what we have so far? The difference is because we are storing new knowledge, we are accumulating knowledge, and we have this kind of personalization, anticipation, adaptivity. Okay, so basically the robot is an interface, the mind is on the cloud, the robot downloads these skills. Next slide, please. So here is one example that you can see how we can use this platform. So basically, what we want to do is to work with perception, reasoning, and interaction. This is a loop, okay? So the robot perceive the environment, the surrounding environment, make decisions on the data acquired from the sensors, and then perform some task or interaction. So we are developing this architecture. We have an example here in this left image where I have, for instance, facial expression, body motion recognition, and voice recognition. So we have multimodality. So we have a lot of things going on. So we have a fusion process where we can use this multimodality in order to make a decision. For instance, if a robot asks for, recognize that an older adult is sad, so the robot is going to look at the facial expression, the body expressions, and is going to recognize that and is going to ask to the older adult, you seem sad. Can I play a song to cheer you up? Let's play a game. So the robot can, in an intelligent way, interact with the older adult. And of course, all this knowledge is going to be stored, okay? To use for learning and to adapt to new context. Next slide, please. So here we have a few videos. Can you play all videos for me, please? So in the first video, in the top left, we can see child-robot interaction. Yes, child-robot interaction, where, previous slide, please. So here we see applications. So we are using these skill stores in different applications. Can you play our videos, please? In the first video, top left, we can see a robot interact with a child with autism in clinical sessions. So the robot has skills for natural language processing to chat with the child, can recognize the emotions, and can invite the child to interact with this robot. Because kids with autism, they have some problems to interact with humans. However, they get engaged, enthusiastic with the use of technology. So they can interact better with robots and animals and pets, for instance, rather than humans. So this is a good way in order to use technology assist children with some disorder. So the robot is extracting facial expression to recognize emotion, as you can see in the middle video, in the left column. So we can recognize facial expression based on a face. We can also have skills to recognize gesture to control prosthetics, to control robot hands, and we have also possibility to recognize activity based on body motion, as in the top right video. So the robot can monitor people, elderly, can recognize what's going on, like walking, running, falling, to prevent fall, right? So if the robot detects some risk situation, the robot can call for a doctor for responsible for the elderly, you know, to say something wrong happening. The person is fell down, something like that. Okay, and the video in the bottom right, you can see a wheelchair controlled by EEG, brainwaves. So the idea is to have an autonomous wheelchair to navigate in an environment, building a map of the environment. At the same time, we can detect the brainwaves to control the wheelchair, to go straight, forward, backward. And of course, if the wheelchair detects some wrong command, like go to the left, and in your left, there is a wall, so the robot's not going to do that action, okay? So next slide, please. So basically, for all the videos that you saw, we are using a framework called Dynamic Bayesian Mixture Models. So this framework, as you can see in the left image, has a multimodal perception architecture where we can grab data from different sensors like cameras, RGBD sensors for depth map. We can then feed this information from different modality to different models. As you can see there, mixture 1, mixture 2. So each mixture means that we can have different learning models there, classifiers, machine learning techniques like reinforcement learning, deep learning, classical machine learning techniques like support vector machines, etc., etc. So for each modality, we can find some uncertainty, and then we can provide rewards or penalties. So we can say mixture 1, which means that modality 1, sensor 1, is more confident than the second sensor. So you provide weights to provide more certainty, more confidence to the modality, so that we can make a fusion of this data to make a decision. So if you know that we can rely on a camera better than laser, then of course we're going to provide more certainties for the models, for the results coming from the camera. Okay, so it's more or less the framework that we work right now. We can combine multiple algorithms of AI into this framework. Next slide, please. So I'm going to start showing some case study, also a component in our skill store on the cloud that is emotion recognition based on facial expression. So as we can see here in the left image, on the top left, we have data sets. So we have images from human actors performing static facial expression, like happy, just smiling, right? Fear, angry, but these images that we have in this database, in this data set, are static images performed by actors. They are not real emotions. They are just figurative, let's say. They are just people pretending some emotion, right? So we try to extract some patterns of facial expression on these images. But also we collect data set based on emotion that is awakened by videos, as you can see in the middle image, the top middle, where people is watching movies, and we try to trigger emotion, real emotions. So we grab this kind of information to learn specific kind of expressions. So how do we handle it? So basically we detect landmarks on the face, as you can see in the top right image, in feature extraction. We detect points on the face, these landmarks. We compute the distance among the landmarks, angles, and the spatial temporal features, which means that we analyzed temporal information. We check the previous information from previous frame. Next frame, we compute angles, acceleration, so we can see the muscles of the face changing over time. And then with this information, statistical data that we extract from handcraft features, we feed machine learning techniques inside our framework, dynamic Bayesian mixture models. And then we can classify. Right now, in the beginning, we could classify 84% of accuracy, of certainty of emotions. But right now, after looking at videos on YouTube and multiple data sets and storing this information on the cloud, we can currently classify over 93, almost 95% in real time of emotion. So we can really detect facial expression in order to estimate the internal state of the person when interact with the robot. Okay, so next slide, please. So the second case study is about active recognition. Again, you use a sensor to detect depth images, which means that we have the perception of the distance of the sensor. Then we can detect a skeleton. We can detect joints of the human body. And then we can extract features like a distance between the joints, angles, velocity, acceleration, and other statistical and moments features. Then we feed the classifier with this information. As you can see in the video right now, the robot is moving, trying to find a human. Once the robot finds the human, we can detect the skeleton, we can extract features, and then the robot can classify what's going on. Now we can see the human falling, so the robot can recognize the person fell down, and then the robot asks if the person needs some help. So the robot can call for assistance, for a doctor, something like that. And we compared our techniques with multiple state-of-the-art techniques, and we are achieving over 94% of accuracy when recognizing walking, running, fighting, sitting down, working on a computer, drinking water. We have multiple classes, okay? Next slide, please. So finally, we can merge all of this into a robot to interact with humans, as the example that I showed in the beginning for child-robot interaction. Next slide. So finally, this last case study is really, really interesting. No robot involved, but AI and human-machine interfaces. So we are using brain waves. So we have a child interact with a computer game, but it's an intelligent game. So the game can adapt and personalize to the child. So we are using a sensor, a headband on the forehead to extract brain waves. Then we are using a lip motion sensor to recognize gesture. So the child can control the game using the hands, not a control, but the hands to control the game. And also extract facial expression to recognize the mood of the child when playing the game. The game is educational games based on reasoning, memory, attention, math, okay? So we can extract brain waves. So the idea is when the concentration level pattern that you detect from the sensor, from EEG, electroencephalography, detects that the concentration is going down, the system is going to adapt and generate some stimulus, visual, auditory, or change the phasing in order to keep the attention of the child while playing a game. This is a neurocognitive training. So we intend over time, using this kind of technology, to improve the attention of the child with attention deficit, ADHD disorder. Okay, so in the second image in your right, we can see that we are going to try to previous slide, please. Yes. So the image in your right, we are trying to generate signatures of brainwaves. So the idea is to collect data from multiple children with non-clinical children, which means that the ones that don't have any disorder, then we extract a signature, a pattern of the brainwaves of concentration. So we represent one signature for those kids. Then when we check a child with a disorder, we try to compare both signatures of brainwaves And we intend, what we want to do is to reduce the similarity between both signatures over time. So the idea is after 3 months playing our games, we want to get closer the signature of the child with the template, the desired one. Of course, they will never going to be the same because a child with disorder is not going to be like a non-clinical child. However, we intend to reduce this problem with attention. Okay, so next slide, please. I'm going to finalize soon. So basically, we extract mathematical features from the EEG. Next slide, please. Then we convert these features into images. Next slide. Next. Yes, next. So we get these features, these mathematical models, and generate an image. The right image that we are looking at are brain waves, the mathematical features, to represent some signatures. And then we feed the signatures into a deep learning model in order to classify if his child is concentrated or not. Next slide, please. So regarding results of this approach, next. Yes. So regarding results, can you play? Yeah, this is just to show the scenarios. First of all, we do some calibration. The first video that you can see in your top left are child playing, just to calibrate the sensor, so we can have an idea what concentration is for that specific child. Okay, different techniques into one, and then we could achieve 97% of certainty when we can detect that the child is concentrated or not. Okay, so we can see in your right image that during our tests, children could concentrate 78% of the time when playing game using hand gesture, and 74% when using traditional games using the mouse. Okay, and we did some transfer learning. We got knowledge that we have stored on the cloud to initialize our deep learning models instead of generating random values. So we could use a model pre-trained for this case here, which means that we did some transfer learning. We got knowledge from other domain when people were using EEG, adults, and we used this knowledge for the children. So we did a transfer learning. So this helped us to achieve 90% of accuracy when 90+% of accuracy when classifying this data. Next slide. Then we did some questionnaire to check the acceptance of the experiment with children. Just to summarize the interview that we did with them, most of them prefer to use the hands to control the games, and they 100% agreed that it's a nice game to play. They don't get bored. The only thing that they complain that playing the game for a long period, they get tired of doing gesture. Okay, next slide. The last one. So basically, just to let you know, to conclude this presentation, is that I'm going to be focused on the UK where I'm working. The UK is investing lots of money in robotics and AI. So this is the future, using smart technology, assistive technology to help humans in business, in agriculture, cobots, collaborative robotics in industry, for automation, etc. So we can see the market right now, estimated value worth $4.5 trillion by 2025. So it's a lot of money for this field, okay? So what kind of investment the UK is doing right now? The government has 93 million to invest in research projects to help industry, SMEs, and also research institutions, universities, with grant proposals, you know? So we have to apply for this project, and then we get money to work in partnership with other universities and the industries, industry in order to improve this field of AI and robotics. Okay, so next slide. So that's it. Thank you very much for your attention.
Thank you so much, Diego. It's really amazing and really interesting presentation and your speech. Thank you so much. And if it's possible, the first point is that I want to say that, you know, I absolutely share your vision when you spoke about high expectation for robots. It's real, to my opinion, it's real huge problem for the area of service robotics. And we in Promobot catch it every day, permanently time. And I absolutely agree with you in this point. So as far as I know, we have a lot of questions for Diego. And dear colleagues, let's start. I know that the first question from City of Perm, from our colleagues, please.
Diego, thank you very much for your interesting program, for your interesting report. And you know, I'm a teacher, and my question is about education. You know, recently, Promobot company opened an online master's degree in service robotics at the Perm Polytechnic University. And the main feature of this program is that students remotely connect to students. It's a virtual robotic laboratory. And what about the educational experience in the field of robotics at Aston University? Share your experience, please. It's really very interesting to us.
Thank you very much for your question. It's really good to know that Promobot is getting engaged with education, and this kind of course is really, really important. And as you mentioned, one thing that's really interesting is it's an online remote course where you mentioned that you are going to use labs and robots in a virtual way, right? This is quite interesting, but of course you have to look at lots of issues like safety. If they are using real robots online, we need to ensure that they're going to do the right moves, the right things. So, but it's really, really, really nice. So at Aston University right now we have a master in AI, where we have modules like robotics and autonomous systems, applied machine learning, deep learning, where we get engaged with machines, not only robots, but any kind of technology involving IoT, Internet of Things, wearable technology. So basically, it's, our courses are on campus right now, right? So I teach robotics and autonomous systems, where we have lots of simulators. We deal with ROS, robot operating systems, and many simulators. For one example, for autonomous vehicles, we have simulators as well, where students can use simulators to learn how to apply machine learning in autonomous systems for later on getting in touch with the robots. Okay, so but we have also modules where they start from scratch. They have to build their own robot, like the Lego approach, you know, where they can have work with Arduinos and pieces. They can do the electronics as well. But we have to think about the future, because with this pandemic, we have to think about online courses right now. And this is a good strategy that you mentioned that Promobot is doing, preparing an environment where students can access online the labs, the robots. Of course, here we have data sets where they can use the data sets and simulations so far, but we need to adapt to allow them to use our robots. They can use right now remotely our server, our GPU server, where they can use the processors online through VPN, right? So they can connect remotely and then use our machines, but not a robot yet.
Yeah. Thank you. Thank you so much, Diego. A lot of questions. Sorry, next question from internet, from YouTube. Diego, you often mention human-robot interaction throughout your talk. Do you think it is essential for a service robot to look like a human during the interaction with a real human. How important is that for the robot to be anthropomorphic or not?
Yeah, it's a good, interesting question. So basically, we have lots of, when you talk about human-robot interactions, we have lots of issues. First of all, the design of the robot, right? So we need to avoid this uncanny valley situation where people get scared or, you know, don't trust on the robot. So there are a lot of studies right now together with psychology where they check the appearance of the robot, first of all, the design, the head, if they should be humanoid or not. Right now, based on state of the art, robots like Pepper they are the ones that they like, you know, that looks like cute robot or pet robot. The robots that look like Germanoids, you know, like the Japanese versions, or that look like babies, they get a little bit scared at the beginning. So it's a matter of time for you to get used to this kind of robot. So the appearance matters, okay, for specific scenarios, for elderly care, for instance. So they have to trust on the robot. So if it's a cute robot, they trust more. So there are lots of studies based on design. This is one point to think about. Another point is, should it be anthropomorphic? So a robot should have hands, human-like hands, not exactly. Grippers might work. We don't need to have legs, like Pepper, for instance, Pepper robot, right? Like now robots, they have legs, but it's very basic, right? Again, this comes back to the first point. The second point is the robot should pay attention, look at the human. This is a good question. Basically, not the robot itself, but the sensors, yes. Because we have to grab
Great.
Yes.
Thank you, Diego. Our next question. Diego, okay, it's not so interesting. Diego, do you think the robots will entirely replace human communication? Is it possible or not?
This is a question that people sometimes think about robotics and AI. They are going to dominate. They are going to do everything. I think we are far from that right now because we have, as I mentioned in the beginning, what are our expectations? What's going to happen?
Sure.
I do believe that they can achieve degrees of intelligence, degrees of, right now, for instance, machine learning can recognize objects better than humans because they use cameras with high resolution or low resolution. They can recognize objects more than humans, faster than us, you know? But this does not mean that they can control things. The future, in my point of view, the future is human in the loop. So we talk about AI and human, okay? So we have to have this coordination, human and robots. When you talk about communication, when you talk about intelligence, we should have human in the loop because yes, we have algorithms nowadays that they can evolve, that they can make autonomous decisions, but we are still far from what we see in movies, in my point of view. But I don't think that we should worry about this right now, and we have to think about collaboration, how humans and robots can work together in order to improve business, wellness, well-being for humans.
Absolutely. I'm on your side. Diego, thank you so much. It was amazing. Thank you so much. We go forward. Our next speakers, I am glad to introduce our next speakers. There are Stanislav Ivanov from Bulgaria and also Craig Webster from United States. Stanislav, PhD in economics from Varna University of Management, Bulgaria, Vice Rector at Varna University of Management, Bulgaria. Craig Webster, PhD in political science from Binghamton University, MBA from Intercollege Cyprus, Associate Professor in the Department of Applied Business Studies at Ball State University, United States. And the topic the topic of report is the economics of service robots in travel, tourism, and hospitality. Really interesting topic. So, colleagues, let's share your thoughts. Stanislav? Craig?
Yes, hello. Today, Stanislav and I will be presenting. Today, Stanislav and I will be presenting on the economics of service robots in travel, tourism, and hospitality. We have a bit of knowledge and experience with this, so we're really pleased to help you with this and discuss this with you today. Next slide, please. A little bit about us. Stanislav is a professor and vice rector at Varna University of Management in Bulgaria. He's also the founder and editor-in-chief of the European Journal of Tourism Research and the editor-in-chief of the new journal, Robotics, which should be excellent. He's also the CEO of Zangador, an important operation. Next slide, please. I'm Craig Webster. I'm associate professor in the College of Business at Ball State University in Muncie and editor-in-chief of Tourism Today. Next slide, please. Part of our background is a few years ago, we started working on the economics of service robots and how we expect them to be incorporated further into travel, tourism, and hospitality. So we're really sort of excited about this. Our book came out last fall, I think it was October in 2019, and it's been fairly successful. And if you want to know more about service robots, and a lot of what we'll talk about today comes from our book, please have a look at our book, and this will help inform you more about how we expect the future to be in terms of the interaction of humans and robots and the incorporation of robots in travel, tourism, and hospitality. Next slide, please.
Thank you, Craig. I will continue with the economics of service robots. Next slide. First, I will present the economic framework of service robots adoption in travel, tourism, and hospitality that is elaborated in greater details in the book. Next slide. So this is the conceptual framework of the economic adoption of service robots in tourism and hospitality. Because the framework is a little bit large, we split it into 2 slides. Next slide, please. The upper part of the framework shows the impact of tourism demand on tourist companies. We have the tourism demand influencing the business processes in companies like marketing, operations, human resources, and finances. This impact goes through in different ways, through the willingness of pay for tourism products, through the perceived service quality, the service process participation. Every company experiences the influence of competitors' actions. However, competitors also experience the influence of tourism demand on their business processes, again, through the same processes like willingness to pay, perceived service quality, and service process participation. If a company decides to use robots, artificial intelligence, instead of human employees, or in addition to human employees, this influences its competitiveness and financial performance. The managers of the company need to perform cost-benefit analysis in order to decide whether it is worth to invest in robotic technologies. Next slide, please. However, these technologies have certain advantages and disadvantages compared to human employees, and there is a substitution versus enhancement effect, which we observe in them. This is the bottom part of the conceptual framework, which shows the relationship between robots, artificial intelligence, and service automation as production factor and compared to human employees. When the company decides to use human employees, it creates demand for human employees on the labor market, and which demand faces the supply of human employees, which is defined by the number of potential human employees that are available on the labor market, the skills that they have, and the wages that they require in order to work in tourism and hospitality. On the other side, if the company decides to use robotic technology, artificial intelligence, and service automation, or RACER for short, the company creates demand for such technologies, which faces the supply for RACER technologies on the RACER market. And this supply is characterized by the technical characteristics of these technologies, the prices of service robots, for example, but also what skills these technologies require in order to be properly used effectively and efficiently by the users. So there is a mutual influence between the supply of human employees and the supply of robotic and artificial intelligence technologies, not only through the prices, but also through the skills that the human resources have and the required skills for the successful use of robotic technologies that are required. Between the human employees and the RACER technologies, we have substitution and enhancement effect. The balance between these depends on various factors, which will be discussed a little bit later in the presentation. But in short, these are the productivity, the marginal rate of substitution, costs, economies of scale, economies of scope, the service capacity of the tourist company, the automation of tasks versus automation of jobs, and also de-skilling versus upskilling of jobs. And now Craig will continue with explanations about the benefits and the costs of using service robots in tourism and hospitality. Next slide, please.
Yeah, one thing we should look at here is in terms of the economics of service robots are the benefits. That is, because there are benefits and costs, we should focus first on the benefits. And why should service robots be adopted? And next slide, please. And there are a lot of benefits to robots. A lot of the benefits are a relationship to human workers and comparisons against human workers. And some have to do with just the capabilities of robots themselves. First of all, robots could possibly work 24 hours a day, 7 days a week, which is in stark contrast to what humans can do. In addition, they can do various tasks. Although many robots now just do one task, it is possible with the proper software and hardware that robots can do multiple tasks and different types of tasks. In another thing to consider is that they will fulfill their work correctly and in a timely manner with the correct software and programming. That is a possibility. We also have the idea that robots can improve constantly the quality of what they do. In addition, one of the key factors here, and we'll talk about this a little bit later when we talk about dirty, dangerous, and dull things, is that robots can do quite routine work repeatedly, something that humans many times don't like to do and don't really excel at. Next slide, please. Again, a lot of this also has to do with comparison of a human workforce. That is, why robots? Well, there are certain things robots don't do. First of all, robots can't really complain. I suppose you could program complaining into them, and I imagine at one time this will happen. Robots don't typically get ill. They may break down and need repair, but they don't get ill the way humans do. And I think now in the era of COVID, I think we can appreciate that. Robots do not yet, and don't, and in the foreseeable future, can't work in ways to organize and strike. They can't spread rumors. They can't discriminate. They can't quit their job without notice. They can't show negative emotions, and they can't shirk from work. Again, these first two slides in terms of why robots really illustrates why the robot is the sort of prototypical Stakhanovite. Next slide, please. So we have this idea that the political capability to organize and strike does always bring up the question of, can these jobs or tasks be replaced with automation? And this comes from Star Wars with different words, of course. Next slide, please. Other reasons why you'd want robots. The first thing is labor cost savings. Since they can work many hours and they don't get salaries the way that humans get salaries, there is a potential for cost savings in terms of labor. In addition, you also have that question of selling things, because many customers see robots as a curiosity, and there are 24 hours a day, 7 days a week availability. You can increase sales. And just as a side note, the Henna Hotel in Japan, had it not been almost entirely staffed by robots, might not have been such a popular and noteworthy thing. I wouldn't be talking about it now. Again, because it's a novelty and its business is based upon that it's robot based. The other issue is planning operations and scheduling. Because they work 24 hours a day, cannot get ill, complain, shirk, organize, strike, and other things, you have more predictability in the system. In addition, there is always that issue of environmental sustainability of the operation. And you have the question of robots not necessarily creating a lot of waste. And it can eliminate a lot of unnecessary activities. Next slide, please. So there's some other aspects. A lot of them are comparisons still with the human, but in some things that are a little bit different. For example, robots lead to an increased role of the customer in the service delivery industry. That is, your interaction with the robot many times is a bit different than it is with the human. So you have more of a prosumer approach. And again, part of this is, I'm old enough to remember the old days when you went to a bank and you had to meet with a bank teller to get money. The interactions that you'd have with a human would be slightly different and much more limited than an ATM now, which is a machine that does the same job, which is distributes money to you. So there's a slightly different process. The other thing is they save employees time. Again, one of the aspects that we're looking at is the 3Ds, dirty, dull, and dangerous, that robots can handle these types of tasks that employees don't typically like to do, or that are a risk, such as the dangerous elements of a workplace. They can enhance what an employee can do. Again, if you have a delivery robot in your hotel, you can send that robot to a room to deliver something instead of you having at the front desk as the only employee, maybe on a night shift, to go up and leave the desk. So it enhances what one employee can do. There is also that issue of the labor force and the flexibility or lack of flexibility in the labor force. Robots give employers a great deal more flexibility in terms of what they can do with their labor. Next slide, please. And then robots can be fun. Robots enhance that perception of service quality. Here's a picture of a child riding on a robot that's vacuuming. They can do things differently. There's still somewhat of a novelty in a lot of aspects. For example, communications in different language and 24 hours a day, 7 days a week. Even professional interpreters may not have so many languages. And of course, humans get tired from translation. That's why simultaneously is translated, or people that work in simultaneous translation have to take regular breaks. You don't need this for a computer and for a robot. And then we have the ideas that robots create value. Again, this goes back to that Henna Hotel in Japan that was able to be entertaining and a novelty because it incorporated robots into its operation. Next slide, please. Again, why robots? Again, robots are still somewhat of a novelty and in a lot of places, and they lead to a positive word of mouth due to the image of being an innovative, high-tech cutting edge company. So the incorporation of robots at this time in our history is a sign of being innovative, new, different. It's a differentiation strategy. Next slide, please. But there are also some costs, and there's good reasons not to use robots at this juncture. Next slide, please. They lack creativity. This becomes, for many of you that have an anomaly that occurs and you're led to an automated response for that, it becomes quite difficult because they can't be creative and respond to quite unique situations. And this is a true limitation of the current robot. Next slide, please. There are other reasons. There's a lack of flexibility in their delivery systems because they can only do what they're programmed to do, very specific tasks. They will not be independent of human supervision. For example, I could talk from my experience last year with a delivery robot in a hotel. A manager still had to follow the robot so that it could make a delivery to my room. It needed that human supervision because it couldn't actually get onto the elevator without human help. Sort of undermining the ability of the robot to do what it should do, which is save labor. They lack a personal approach because they're programmed and they're robots. They're not humans, and they can't interact the way humans do. They can orient only in structured situations, and they can't think outside of that, which is the benefit of what humans can bring to the table. There are privacy and security concerns. Facial recognition technology and other issues lead to the question of where are those data going to and who controls those data. And then there's also that question of negative publicity. That is, robots could lead to the perception that a company is considering robots more important than humans. Next slide, please. Again, there's this more sort of historical thing that humans have perceived a lot of labor-saving technologies and innovations as being a threat to human employees. The Luddites, which is from, the concept comes from industrialized in England, were afraid that the machines would take over the things. And there's a long history of this, that machines were taking over the jobs of humans and replacing humans with another entity, and machines. Next slide, please. So, and there's the other question of different industries being put out of business because of the change in labor by using robotized labor. And there's an example, there was a time when the horse versus the automobile was a big issue. And there are benefits of an automobile over the horse, and there are benefits of a horse over an automobile. But it largely put some businesses out of business effectively. Next slide, please. And why not robots? Robots aren't really consumers the way that many consumers are consumers. Here's a picture of Stanislav going to the spa. And again, if you pay a human employee their wage, the human employee will go, and there's a trickle down effect into the economy. There's a whole ramifications for where people spend their money and what they do with their money that you have in a normal economy in which you have human labor. When you've replaced human labor by robots, you don't have necessarily the thriving service industries that are dependent upon a wage labor-based economy. So there is Stanislav spending some of his good money at a spa. And had we had a robotic Stanislav Ivanov, he probably wouldn't go to the spa, but he might need some repairs, but it wouldn't be at a spa. Next slide, please. So there's a question of how you fit that balance of robotized labor versus human labor. And that's something Stanislav and I are looking into, is what's sort of a good ratio of robots to humans or humans to robots. There are questions of company characteristics and culture. Does a company want to be innovative and have lots of robots, or does it want to be sort of an old style entity and use lots of human labor? Those are sort of company culture questions and characteristics of what the company wants to do. And then you have the other question of relative costs. of labor and technology. And if labor is inexpensive, why would you use expensive technology? If you need flexibility in labor, maybe you want to use more technology. Or so you have this question of the degree of technological capabilities. What is the company capable of doing? You have also the question of the consumer. Does the consumer want to interact with robots and be served by robots? And there are some interesting things to be said about who wants it and who doesn't. That's another thing Stanislav and I have looked quite closely into. Then we have cultural characteristics of consumers and service providers. Again, it's no mistake or accident that the first robot, well, the Hana Hotel in Japan is in Japan, because that the culture there of Japan is quite pro-robot and robot friendly. It might be different in different places. And then you have other safety characteristics of robots, from which they can be a risk or something that is rewarded in terms of safety. Next slide, please. Now we move back to Stanislav, who will, or no, I'll talk this one, then we move to Stanislav. So the question of that, it's a question of a balance. What's the right balance in terms of how much automation using robots is needed versus the other end? And there could be different markets that are looked at. So we have this bifurcation of a high tech and a high touch economy, a high tech economy being those entities that want to work, those businesses and companies that want to work within a high tech way, and other ones that see a lucrative market in the high touch market. Again, sometimes we talk about sort of different ways of delivering the same thing. For example, your massage chair is a machine that delivers a massage. Would people like a massage from a chair? How much cheaper does it have to be? How much are you willing to go to a human to massage you? More, what are the risks of working with a human? The cost of human labor versus the massage chair? It brings up all sorts of issues about what is the best way to deliver this. And now I think we move to Stanislav, who will talk a bit more.
Thank you, Craig. I will continue with the substitution versus the enhancement effect of human employees and robots. Next slide, please. So this problem of robots versus humans was discussed many decades ago. So we can see that it was popular in cartoons. On a robot was created to enhance Zayats in Ну погоди. Next slide, please. One of the most, when we talk about substitution versus enhancement, we need to consider that we talk first and foremost about automation of tasks. So versus automation of jobs. And one of the most influential paper published 3 years ago, this is probably the most cited paper in the field of robonomics, with over 6,000 citations just for 3 years, stated that nearly 50% of US jobs are susceptible to computerization. However, if we look deeper into the methodology that the authors use, we see that they talk about automation of jobs. However, in practice, automation happens on task level. Task level, like inputting data into a reservation system, cleaning floor, delivering pizza, producing a sales forecast, delivering a room service order, etc. Next slide, please. Robotic technologies, they always have both substitution and enhancement effects simultaneously. And the balance depends on the automation of tasks versus automation of jobs, the relative productivity of robots and human employees, the service capacity of the company. Next slide, please. When we talk about the relative productivity, we need to see how much revenue the robotic technologies generate compared to the costs that are necessary to to maintain these robotic technologies. So if the revenue per dollar cost for robotic technologies is greater than the revenue per dollar of labor costs, then we can see that the robots are more productive. So if we spend 1,000 euros for robot technologies and they generate 3,000 euros, but we spend 1,000 euros for labor and labor produces 2,000 euros as revenue, obviously the robots are more productive. In that case, the company will have stimuli to use robotic technologies and to substitute the human employees. However, here we have one pitfall. It is very easy to calculate the costs, the labor costs and the robotic related costs. However, it is very difficult to calculate the revenues that come from the robots and the revenues that come from labor. For example, when Craig ordered his room service, the hotel made costs for the robot and for labor. They can be calculated, but how will the revenues be divided between the robot and the human employee? This is a question that needs to be answered in the future. Next slide, please. When we talk about the automation of a task versus automation of jobs, we can say that every job is a set of tasks. And when robots automate specific tasks within a particular job position, and if the same job position can be performed by a person who has lower education, then we talk about de-skilling of jobs. Practically, a job consisted of, let's say, 20 tasks. Now it will consist of only 15 tasks. And a person with a lower education and with a lower salary will be able to perform it. So this is de-skilling. And here we talk about that the substitution effect prevails. However, we can have also the opposite situation when the use of robotic technologies forces the employee to have more skills because they will need to perform new tasks which they previously did not perform. This is called upskilling of jobs. In that situation, enhancement effect prevails. Next slide, please. The service capacity is also important. If, for example, the robots can expand the service capacity of the company, or they can increase its utilization without without the need for the company to hire additional staff, or if the additional revenues that the robots generate are higher than the additional costs for human employees, then what we can say? We can say that practically the robots increase the productivity of the company and they decrease the costs to serve one customer. In that situation, the enhancement effect prevails. Next slide, please. However, if we have the opposite situation, we have a company with a fixed and well-utilized capacity. The possibilities to increase the revenues are marginal. They are very little. For example, a hotel with a very high occupancy rate, or if the maximum demand is limited by this fixed capacity. In that case, the company will focus on costs. The profit of the company can be increased by decreasing costs. And it will focus on the substitution effect of robotic technologies. Next slide, please. So what is the exact mechanism of substitution and enhancement? Next slide. Let's say that we have one simple company with 3 processes that consists of different tasks and 3 different job positions. The rows show the tasks that belong to a particular process, while the columns, they show the tasks that are performed by a particular job position. Next slide. When we introduce service robots in the company, different effects happen. First, some tasks are eliminated. These are the tasks with dark gray. Other tasks will be reallocated. This is with light gray. Third group of tasks, they will not be changed, but also there will be newly created tasks. So what will happen? With job position 1, it will be completely eliminated job position, because practically 6 out of 8 tasks will be automated, while the other 2 tasks can be relocated to another job position. So it will be eliminated job position. For job position 2, it will be enriched with tasks from other job positions. This is because 2 of the tasks will be moved from job position 1 to it. Job position 3 will be enhanced with newly created tasks, which did not exist before the introduction of the service robots in the company, while a new job position 4 will be created. What can we say about the processes? Process 1 will be completely automated. Probably the process will still continue to be performed in the company, but it will not be performed by human employees, but by service robots. Process 2 will be partially automated. Process 3 will be not automated, while process 4 will be newly created. And the next slide shows how the processes and the job positions will look like for human employees after the automation. Job position 1 is not included anymore, while process 1 is automated. Next slide. So what we can summarize is that robots and automation technologies in general, they eliminate tasks for some human jobs. They help reallocate tasks to other jobs and create new tasks for existing and new job positions. This means that for some jobs, substitution effect will predominate, while for other job positions, we shall have enhancement effect. But we shall have always both. The question is, what's the balance? Next slide. And what Craig and I would like to tell you is technology is a tool. It's not a goal. Next. Because we can have a wonderful technology, but we need to use it wisely, effectively, and efficiently. Because we can have fantastic robots that we want to use in a hotel, but if we don't make our calculations properly, if we don't have a program for their proper introduction in the company, in 1 week they may be used for completely different things. So thank you so much, and we are available for your questions.
Thank you so much, Stanislav and Craig. Thank you so much. It was amazing, really interesting speeches. Actually, it was so interesting lesson for me because I am producer and manufacturing robots, and I understand that you provided and developed absolutely huge, interesting and useful work, and that more important that it's really real practice information from field market. I think that it's really useful information for all development of robotics. Thank you so much. We have and also now I understand why not robots. Robots don't go to the spa center. Yeah, it's the main point. And if our guys from sales department listen to us, please remember it. It's the main argument. It's a joke, of course. Thank you so much. We have a lot of questions. And I know that our city of PEM waiting that ask the question the first. Alex, please, welcome.
Hello. I have a question for you. As you've mentioned, robots are very good at performing monotonous work, right? But what about some critical situations, some emergency situations? Well, they are not good at them, right? So, and right now we have to have a human who can act, who can make a decision, make a right decision in this situation. What do you think? Will it be a human-only position to make critical decisions in emergency situations? Because, for example, if we are speaking about the hotel industry, So we evaluate the quality of service by the way the people solve our problems. For example, when we fail to check in at the hotel. So what do you think about it? Thank you.
Okay, shall I answer the question? Great. Okay, what I can say is that the previous speaker mentioned that we have to keep the human in the loop. So we can have a human on the loop, in the loop, and off the loop. So in some situations, or for some decisions, it is much better to have a human making the decision. So emergency situations are probably some of these situations where the human will be able to make a decision faster and also to consider all the different aspects of the emergency. However, that's why in that case, probably a robot is not a good to be used to make the decision by itself. However, the robot will be able to help, for example, if there is a robot that can carry a person, so that if there is a fire in the hotel, so that the robot will be able to help by order of a human to carry the guest outside. But of course, the decision itself should be made by the human, but the implementation can be performed by a robot, allowing, provided the circumstances allow this. While in other cases, of course, for simple things like check-in, check-out, provision of information about the destination, these are routine tasks which a robot can easily handle. And by the way, for these things, it's not even necessary to have a robot. A simple kiosk, check-in kiosk, which is not a robot, can do the work.
Stanislav, thank you. Thank you so much. So next question, please choose who will answer. In your opinion, what will prevail, high tech or high touch? Do you think the high touch side become a more affordable and alternative to high tech? So, for example, instead of hiring a teacher, a person would have to use their smartphone for distance education. I think that's a good question.
Well, let me answer this, I think, and Stanislav, let me know if you disagree with me or you can embellish. I think that we're going to see the formation of two different markets. I think the majority of the market will be a high-tech market because it will deliver the services that people demand as long as it's cost-effective. There will be those people that want a high-touch market that are able to pay for those services delivered by a human, using human intelligence and the interactive capabilities of humans that robots, at least in the foreseeable future, will not have. So I think there will be a sort of a large market, for example, hotels that have no robots or virtually no robots, and everything's done by a human. And if there's a cost-effective way of having a fully robotized or automated hotel, you'll have that as well. But there has to be, from what the research Stanislav and I do, is we see that people expect a cost savings when robots are brought into the picture. Stanislav, I don't know if you want to embellish or disagree with anything.
Yeah, I can completely confirm what you said. Our research practically showed that that customers want on average something like at least 10% discount, and on average about 20% discount for tourism services that are completely automated, delivered by by robots, compared to a service completely delivered by human. So a hotel which is completely staffed by human is, let's say, 100 euros. If the service is completely automated, the price should be at least 10-20% lower. So about 80 euros. This is what we have found in our global survey.
Interesting, got it. Thank you so much. A lot of questions. So next question. I think that it's rather interesting too. From question is a bit of a segue to the next talk. but where do you stand on augmented humans and cyborgs? Do you think they have a place in your high-tech, high-touch theory as one of those cases from the gray area? Where is the cyborgs?
Stanislav, I'll let you answer that one.
Yeah, okay. What can I say is that for the moment, Craig and I consider robots and humans as two distinct species, not species that are crossbreeding. So this is what we focus at the moment. So human robot, human enhancement through such technologies will probably happen in the next 3, 4, 5 decades. We don't think that it will happen sooner, but nobody knows. Nobody knows. So we might be surprised.
Okay. Who knows? Okay. Clear. Next question. 5 seconds. Can robots be utilized in medicine? Do you think robots will be more in demand after the coronavirus pandemic?
Yes, yes. I say yes, yes, and I'll let Stanislav embellish.
Yeah, what I can say is that definitely robots have a huge role to play in medicine in different aspects.
Massive.
First, they can be used for disinfection of the hospitals. Second, they can help transporting things, items in the hospitals. They can be used to clean the floors, but also robots can be used to assist surgeons in performing medical surgeries, like and such robots already exist, like Da Vinci robots. So practically, it will be of course, it's not completely automated. It supports, it enhances, it doesn't substitute. But the type of Star Wars robots that substitute humans and they have human and beyond human level intelligence, probably this is far beyond into the future, if it ever comes.
Yeah, and the next last question is about the future too. So if we download the human consciousness into the robot, who is he going to be? What are going to call it? Do you believe that it's possible?
Well, that's an interesting question, because you start dealing with sort of, when is a robot a human? And the ethical dimension of that is when they get human rights. So it really goes back to our definition of what is a human. And this has a massive ethical connotations, I think, for a society. Again, we're pretty far away from that, but it's still a conceivable question to ask. And the ethical dimensions of that are massive. Because if we start considering robots human, then we might have to treat them differently. And that's just a matter of downloading human consciousness, whatever that is. And I'm not even sure if we can ever define really what human consciousness is, because it's first of all, it's socially based, that concept, and defined, and it's massive. It's not a very specific and narrow thing. I don't know if Stanislav agrees or disagrees or can embellish.
I completely agree with you, and practically I have nothing to add. Thank you.
Thank you so much. Thank you so much, Craig. Thank you so much, Stanislav. It was so pleasure to discuss with you. Thank you so for your time. Thank you that you connect.
Thank you. Большое спасибо.
Спасибо. So we are go next to next speaker. И я, наверное, могу перейти на русский, чтобы представить нашего следующего спикера. Илья Чекх, генеральный директор компании «Моторика», производитель биоэлектрических протезов, предприниматель года по версии Ernst & Young, со своим докладом, очень интересным докладом «Киборгизация. Как робототехника изменит облик человека в будущем». Илья, тебе слово.
Да, Леш, большое спасибо за представление. Всем привет, друзья, тех, кто нас смотрит, тех, кто нас здесь присутствует. Первый раз я в Перми, давно хотел, собственно, к ребятам заехать, посмотреть на Центр российской робототехники.
For a long time I've been wanting to visit this city, to visit the center of Russian robotics, and it's really impressive. We've been talking about how robots are going to replace people, and now we are going to speak about when keyboards are going to replace both. Robotics is very different, and my team, my company, our aim is to develop technologies, develop robotic and solutions that could have an impact on the image of human, our functionality, on our longevity. And today I'm going to give you an overview on the human augmentation, how prosthetic limbs are developed, what we have already done, and what we are going to do in the future. Starting with history. The start of the process of developing such devices for human augmentation is the middle of the 20th century. In 1958, they created the first artificial hand with an interface that could read the gestures, phantom gestures of that person was making, and it would give it the command to the limb. This was the first example of an interface in an attempt to control an external device and to modify human person. Then, in 1985, the first artificial heart was implanted, and at present over 2,000 people have received such artificial hearts and are living with it. In 2006, the first organic eye, Argus 2, was implanted. This is not completely functional eyesight, but the person can only see some images, some hazy objects, and the visual brain has been implanted with an electrode network that is stimulated with electric currents, and it allows a person to see some images in their head. An important event happened in 2012 during the London Olympics, and South African athletes, Oscar Pistorius, took part in those Olympics. He had two prosthetic legs. He was faster than any professional sportsman, and after that he was disqualified because he was too fast. And so he had to run among Paralympic athletes. This is the first important event when a person who was challenged, physically challenged, actually outran healthy athletes. And recently, another important event happened. The Neuralink company belonging to Elon Musk has demonstrated the first prototype of neuro interface performed on guinea pigs, and the number of electrodes is impressive. It's over 1,000 channels of electrodes. So the quality of this interface can enable it. If you put such electrodes on motor brain, you can read the movement of fingers and make robotic processes perform those commands. In general, if you collect all the technologies around the world that are replacing different organs and limbs. About 70% of human body can now be replaced by functional analogs. It's clear that many of those devices are still clinically tested and don't function perfectly, but still there are already artificial livers, hearts, vessels, bloods, eyes, ears, hands and legs. And so in fact, everything that is vital can be upgraded and replaced. And a person with such modifications will live longer than they would live otherwise. We'll go a little bit around the main spheres of our work, the upper limbs and lower limbs. I'd start with lower limbs. Prostheses, because today if a person can use the most up-to-date prosthetic leg, which are now produced only in the US, and you can imagine that a person is walking towards you in the street wearing pants, you will never understand that this person is wearing prosthetic legs. And it is this engineer who is developing such prosthetic legs. He himself lost his legs while climbing, and now he has created the most modern laboratory for creating such prosthetic legs. And so the functionality of prosthetic legs has now reached the maximum. And so you cannot see the difference between a person walking using their own legs and prosthetic legs. And now this sphere is developing in a little different way. I've already mentioned this athlete. He has special prostheses that use the biomechanics of a cheetah's paw, which enables him to run a lot faster than normal people. There are other prosthetic legs that can enable people to climb rocks, and they are based on rock goats, mountain goats. Now prosthetic legs are specializing in some narrow spheres for specific people, and the important thing is that any person can have a set of those prosthetic legs. Like some people choose what trainers they will wear today, a person can choose what prosthetic legs they will wear today. If they, depending on whether they want to run faster or look higher or taller or etc. So a person gets enhanced abilities in this way. As for hand prostheses, for the past 7 years, our team has been working in this field. We know everything that is going on in the world about it. And I'll tell you about what we do and why the future is with us. First, we need to point out that the upper limb prosthesis, there's still a long way to perfection. Still dozens of years will take until it reaches perfection. We were young and unexperienced when we started, and we thought that we would take about a couple of years to make perfect limbs, and after 4 years we realized that it would take us another 30 years to make a perfect prosthetic hand. From the very start in our team, we took the ideology that we are not going to make prosthetic hands that would just be able to take something and carry something and put it down. For people who live without a hand for a long time, they get used to working with just one hand, and they don't need another limb to grasp things. So we decided that we would make prosthetic hands which would function as a gadget, which would make a person lives a more convenient way for interacting with the digital world. And now the digital world is more important than the physical world. For us, it's more important to sit with a cell phone and to watch something on television than to actually make something by hand. So all our prosthetic hands are made to function in a digital way. They all work with touch screens, they have GSM modules, they can be used as touch pads, you can pay for things using your prosthetic hands, you can take telephone calls, you can give out Wi-Fi. And we are developing in this paradigm. Our task for the future several years is to integrate the whole functionality of a phone into that prosthetic hand, so that a person would not need any other gadgets, remote control, intelligent house control, coffee machine control. It's all possible technically, and this is what we're trying to do. And the second aspect is the design. Prosthetic hand should look good, it should cause admiration, it should show that a person is not like everybody else. It's not disability, rather it's an advantage. And the greatest technological barriers in hand prostheses have not been overcome yet, and there's a lot to do there. First and foremost, it's the feedback, the senses, the most important thing that our fingers have. It's the sensibility. You can touch things, you can understand its temperature, its structure, and so on. And a prosthetic hand cannot do that at the moment. And as soon as artificial skin is created, something that could give them senses to the brain and to the nervous system, and give a very clear native reaction when you have touched something or have taken something, then at this moment we can think of replacing your actual hand with a prosthetic hand, just to try something new. And as the previous speakers have said, a lot of work is still there in this field, and maybe it will be reproduced massively in the next 25 years. There are other companies that are trying to do the same things, and the image belongs to some Italian scholars who have achieved to get some basic sense that is transmitted from a prosthetic hand. But until it becomes mass market, a long time will pass.
So we do have a lot of prototypes. Nearly all organs have their prototypes, bionic prototypes, artificial ones. However, just as we've said about the sensibility for the prosthetics, the artificial organs, we need to have a lot of time for clinical trials, for simplifications, for improvement, and so on and so forth. So today, the safest application of invasive technologies is about the electric chips, which could be implanted into hands or legs, and, for example, to record your ID, your transport card. So these are the things that the biohackers do, and they are trying to improve their bodies. Well, why not? It's a kind of improvement, upgrade. You don't have to carry a lot of cards. You just touch the screen with your hand, and it clearly understands what you want to do. And here is one more very interesting case with this young man. The point is that he was born with a disorder of seeing the world in white and black, and he had surgery in Barcelona. he had special electrodes implanted in the brain, and he had special camera that detects the colors around him and sends the signals to the inner ear and transfers the sound into colors. So it means that he could see the colors in the sound spectrum. So the case is exciting as the fact is that, well, he's from Great Britain, and once he decided to change his passport, so he was not allowed to be photographed with antenna, and he was trying to prove that this is his integral part. This is not just glasses that can be taken off. In fact, this is the part of his body, just like when you can't put off your hand. So he managed to prove that this is his integral part, and he is considered to be the first cyborg with passport. And here we have one more ethical side of the issue that has already been mentioned here somehow. The point is that we have a person with a handle and prosthesis. In case anything happens, for example, this prosthesis can be broken. So in this case, what crime it is? Is it damage to the property, just like, for example, damage to a smartphone, or it's about damages to the body? As far as prosthesis is a part of the body, it's just like when you break your hand. And these are the questions which are being asked in the society, and we, as the developers and designers, we're trying to make people aware of these issues. We're trying to communicate within the expert communities and trying to develop this area. As far as we clearly understand that it's quite inevitable, so sooner or later we are going to be modified by different implants and technologies. So if we want to be competitive in the future world, in this case, we have to do that, just as we all study English because we understand that we can't live without English. So the same is about the implants in the future. So here are a number of pictures for the prototypes of different organs, including artificial lungs. So left bottom, a very interesting thing, in kind of it's a pancreatic gland with a year's storage of insulin, and it is integrated in the human body and monitors the glucose level in the body, in blood, and ejects the insulin into the blood. And the point is that the more modifications the human body has, the more critical this cybersecurity issue is. So just like, for example, any phone can be hacked and have an access to any bank account, the same can be with the pancreatic gland, so it can be hacked, and so it is programmed via YouTube connection, so in this case it can be hacked, and an insulin dose could be injected into the blood to kill a person. This is one more point that should be paid special attention to in terms of the device security and safety. Well, as the society is being transformed, we could see, well, to be more specific, we can see that different events, competitions, concerts, and movies will be transformed to have more cyborgs in them. So Cyberthlon is a championship. So it took place in 2010. It's a kind of an analog for Paralympics. But for people who use high-tech rehabilitation devices, well, last year it had only 6 categories: hand prosthesis, leg prosthesis, wheelchairs with electric simulations, and so on. But the point is that, unlike the Paralympics, people are not limited in the technologies that they use. So the more advanced the technology is, the more chances you have to win. So the point is that nearly any research team, companies, research centers can participate in this competition. Even the prestigious are not satisfied and are not proved to be safe, so you can apply to this competition. So when we visited this competition, we got acquainted with one team from Japan. They had a very huge camera with a lot of cables connected to the hand prostheses, a lot of different tubes and cables. It looks really very exciting, so I should have added the picture to the presentation. But that's the point of this competition. So in fact, it's a kind of a platform to test, to pilot, to market, to introduce these technologies and teams and people who would like to improve themselves. And I've already mentioned this point. We are the developers, and we should think about the safety and security of the devices. And very often I say that my team could be burned for all that we have done one day. And our task today is to make people aware of this area, and our teams are developing the foundations, the background for the world that we are going to have in the future. And what foundation we have will impact the future, whether we shall use it for the benefit or find more disadvantages in this. We've been developing this area for 5 years, so we have introduced more than 1,500 prostheses in 12 countries, and right now we are a leading company in Russia, in Eastern Europe, in SIS countries, CIS countries in this area. And just to recap my presentation, I will just, I'd like to cite Yuval Noah Harari, the author of Homo Deus. You want to know how super-intelligent cyborgs might treat ordinary flesh and blood humans. Better start by investigating how humans treat their less intelligent animal cousins. So therefore, I wish you all the best, and I wish us to have more implants in the future. Well, super, Ilya, thanks a lot. So more implants in the future. I believe that this is the words for Promobot conference.
By English, I start one more.
Несколько слов на английском языке о наших информационных партнерах.
Website that publishes the latest researches and discoveries in science, health, the environment, technology, and more. And we are really glad to have such partners today on our Promobot Talks. Thank you so much. Ilya,
yes, more implants in the future. So let us get back to our questions. Well, in fact, we have a lot of them, so let us try to choose the most important ones. The first question from our Russian information partner, from high-tech platform.
Интересуется, когда с помощью нейроинтерфейса можно будет читать память человека, оцифровка сознания, когда будет возможно. А также я присоединяюсь к другой вопрос.
Also, I'd like to add one more question to this one.
Ваш прогноз, когда нейроинтерфейс от Илона Маска станет
when do the prosthetics from Elon Musk be available to all people? As for the neural interface from Elon Musk, I believe this is the state-of-the-art project which is rapidly developed in this area. So now they are focused more on the interface for academic research for the universities rather than for ordinary users. But in fact, when they are done with the technologies, they will move to the consumer market and the interface will be mass product. But considering the interface, it's really very difficult in terms of the life of these prostheses. Well, I believe that these products could become mass in 10 years. Well, in terms of technology, they could be ready in 5 years, but in order to verify their safety, so we should have very long tests, and only then they could be introduced to the mass market. As for reading the memory and conscious digitalization, I think this is the direct consequence of the development of these interfaces, and by now we do have some experiments to transfer the thoughts from one person to the other via the neural interfaces, and they were quite successful. So one person imagined something and the person on the other end stimulated the cortex and triggered the images of the other person. Well, there were some limitations, some barriers, well, but still quite interesting experience and experiments. Well, I believe it is quite achievable, but it's a long-term goal. So how long do you think? Well, about 40 years at least. So first we start, well, I'm talking about a fully fledged, full replication of conscious. Well, in 10 years we will start to reproduce some images, some memory, part of the memory, but as for the whole memory, that will take a long time.
Some questions from our English-speaking audience. Assuming all the people become cyborgs, are we going to be unified human entity, or they will still be different sexes, nationalities, and identities?
Очень интересный вопрос.
That's a very interesting question, and I believe that we will have more diversity with the appearance of new technologies, new artificial organs. In this case, a perfect hand prosthesis does mean that you can have only 2 hands. You could have 4 hands. Why not? So the same is true for the other things. As for nationality, I don't think there's anything new on the market. So I'm sure. Yes, speak about gender. Will gender be changed? So will there be a third gender, fourth one? Well, just like when you just choose your gender in your smartphone. Well, I do agree with you in many aspects. Sorry to interrupt you, but this is what I'm thinking about, and I believe that there will be some battles and maybe kind of a group of people who are more efficient with not 2 hands but 4 hands.
Do you think professional sports will be in any way different from what we have today? Should we expect augmented Olympics and events of that nature?
Yes, we have already spoken about that. I believe that all aspects of society life will be changed. We can have new concepts, new sport competitions, even pop culture, probably new movies, and so everything will be adopted to the new reality. And even if we look at the society now, maybe nothing comes to my mind if speaking about a movie with no hero, with a prosthetic hand or arm. So even now it is really very a developing area. But still I believe that there will be people who will stick to the classical Olympics, who will be interested in some classical Olympic competitions that will stay with us. And even now, if we look at the society, we see some agrarian sectors who live in nature, and it's just the reality, and this is a feature of the society, part of the society, to live in the past and to think that it was better in the past rather than it is now. So people will not develop on the technologies,
Илья,
and
спасибо
in this
большое. К
way our
сожалению,
society
время
will
нас
really be very
поджимает,
diverse.
поэтому огромное
So
количество
the time in
вопросов
pressing,
мы не успели
yes,
задать.
so we have a
Но
lot
вы
of
знаете, я
questions,
вот просто
but
еще раз не могу не
I
отметить,
just
Илья, я
want to note one more
очень рад, что
time
ты
to
приехал к нам в
emphasize
Пермь.
that I'm
Мы
really
там,
very
да, с
glad to
тобой
see you here
заочно на
in
Зуме, либо
Palm.
всегда там считаю, что знакомы.
So, and
И жалко, что
it's
я
really
сегодня не
pity
там. У
that
нас будет
I'm not
обязательно
in
еще
Palm,
возможность
and I believe that we will
такого в
have such an
качестве со
opportunity
своей
to
стороны
communicate. On
заключительного
my
слова
side,
про
just
Promobot Talks
to
хотел бы
recap
поблагодарить всех
Promobots Talks,
спикеров,
I'd like
кто
to
смог
thank
добраться до
all the
Перми,
speakers who
кто смог
managed
найти
to be in
время и
Palm, who could
подключиться
find
к
the
нам.
time to participate
The
in
first
this
of all, our
conference.
forum
And
speakers from Bulgaria, United States, and United Kingdom. Thank you so much, dear colleagues. Также, конечно, наших ребят
and I'd like also
из
to thank
Promobot,
our
Андрей Носов, который
colleagues from Promobot,
сегодня
Andrei
очень
Nosov,
классную открыл
so
Promobot
who
Talks. И, конечно,
opened
все те,
our
кто
conference,
готовил нашу
Promobot Talks,
конференцию в
and
таком
I'd like to
формате.
thank everyone who
После пандемии я знаю,
organized
что все волновались,
this
но судя по
conference.
количеству
I'm sure that
участников
they
в
were really very nervous
онлайне,
about this, but considering the
успели
number of
периодически
the
написать,
attendees, online
думаю, что этот
attendees, I can
экспириенс
see that
был
this
удачный.
experience
И,
was really very
конечно, если мы
successful,
получим
and
хорошие
if
там,
we
отзывы и в
get the
целом
right
поддержку,
response and
то
feedback and
мы такой
support from the
формат,
users, I believe that
наверное, для себя
this
примем как
format will
стандартный. А это
become a
значит,
standard for us, and
что
it means
Илья и
that
остальные коллеги, мы
Ilya
будем
and
вас
other
периодически на
colleagues
Promobot Talks, если вы не против,
will be
приглашать.
invited to
Да.
Promobot Talks.
Коллеги, все участники,
So, dear
команда
colleagues,
Promobot,
attendees, and
спикеры,
Promobot
еще
team
раз
and
вам
speakers,
огромное
one more time,
спасибо.
thank you very much.
Я получил огромное
So, it was really a
удовольствие
pleasure for me
сегодня
to
слушать вас,
listen to your
экспертов. Мне кажется, что
presentations,
получилась
to
очень
you experts. I
интересная,
believe that our
популярная и при
conversation
этом
was really
экспертная
very
сессия.
fruitful and
Еще раз
exciting.
вам большое спасибо и до новых
One more
встреч.
time, thank you very much.
Всего доброго.